We built 52 reactors there.
There is no affordable nuclear.
We believe that those small modular reactors will probably be successful.
Nuclear power is an incredibly debated topic all around the globe. Many countries are making enormous pushes toward nuclear energy, while others are scrapping it to be replaced by other renewables. Politicians around the world are also incredibly split on the topic, with some bringing it into their agenda and others outright fighting it. However, ever since its invention in 1942, scientists have been looking to find ways to make a better, safer form of energy that could be thoroughly incorporated into our energy grid. As a result, many ideas for new types of reactors have been proposed. One of these such reactors was the Fort St. Vrain nuclear generating station. Throughout the late 1900s, the issues of climate change began to become more prevalent in society. Faced with an ever-worsening climate crisis, the Fort St. Vrain nuclear generating station was one of the many solutions created to solve this problem. This commercial power plant was a next-generation, high-temperature, gas-cooled reactor built near the town of Platteville in Weld County, Colorado. Although the nuclear plant was not very successful, it still served as an extremely efficient proof-of-concept power producer, as well as a major step forward in nuclear engineering. It also served as a major turning point in history, paving the way for current nuclear technologies and safety, and demonstrating optimal cleanup processes for shutdown and destroyed reactors. In 1934, physicist Enrico Fermi made a groundbreaking discovery when he found that atoms could be split into lighter atoms by bombarding them with neutrons. This discovery paved the way for our understanding of nuclear fission and its immense energy potential. A lot of research culminated in Fermi's team creating the first controlled nuclear chain reaction in 1942 with the Chicago Pile 1 reactor. Initially, nuclear research focused on developing weapons during World War II, but as electricity demand soared, attention shifted to harnessing nuclear energy for peaceful purposes. This shift led to the construction of the experimental breeder Reactor 1, which produced the first electricity from nuclear power in 1951. Today, nuclear energy supplies approximately 9 to 10% of the world's energy needs. Despite its contributions, the industry has faced significant challenges. The accidents at 3 Mile Island in 1979, Chernobyl in 1986, and Fukushima in 2011 highlighted the risks associated with nuclear power, leading to heightened public concerns and debates about its safety and future viability. The Fort St. Vrain nuclear generating station was Colorado's first and only nuclear power plant. The Public Service Company of Colorado announced plans to build the plant on March 13, 1965. Visually distinct from conventional nuclear power generators, the Fort St. Vrain plant lacked the typical large white concrete funnels seen in other reactors worldwide. This is because the Fort St. Vrain power plant was a new, next-generation type of generator known as a high-temperature gas-cooled reactor. In a reactor, there are three main components: the fuel rods, usually made of uranium, which are bombarded with neutrons to generate heat; the coolant, which is used to cool the rods and produce steam to turn turbines; and the moderator, which is used to slow neutrons to allow for nuclear fission. Typical nuclear reactors, known as pressurized water reactors, use water to act as both the coolant and the moderator. HTGRs instead use graphite as the moderator and helium as the coolant. This design is considered to be significantly safer, as graphite has high thermal inertia, meaning that it resists changes in temperature very well. As a result, a failure in the helium coolant system would mean that temperature increases would be gradual, affording operators crucial time for intervention. Furthermore, helium's inert properties ensure that it remains non-radioactive. Work to build the nuclear reactor began in September of 1968. Total construction costs reached around $200 million, with initial tests beginning in 1972 and the first commercial power distributed in July of 1979. The reactor showed a thermal efficiency of 39 to 40%, which was amazing for a steam cycle power plant. Along with that, it had a maximum burnup, or amount of energy extracted from the fuel, of 90,000 megawatt days per metric ton of heavy metal. This was incredible compared to the normal light water reactors with burnups of 10,000 to 40,000 megawatt days per ton. However, the life of the plant was not all smooth sailing, not even close in reality. Less than a year after it began producing electricity, core temperature fluctuations were seen, and a few days later, the reactor was shut down so repairs could be made. Issues like this continued throughout the plant's life, with the biggest problem originating from the helium circulator. The small molecules of helium were very hard to keep contained, and needed extreme measures to keep them sealed in the loop. Throughout the rest of the 1970s, many issues continued to rise, including fires, temperature control issues, and leakages. Issues with moisture buildup resulting from the sealing mechanisms used on the helium circulator caused large issues with corrosion throughout the plant. As time progressed, the Fort St. Vrain generating station began to face electrical issues in their systems as well. Often, backup systems failed to come online, leading to more moisture buildup issues, causing even more electrical problems. Due to the corrosion and electrical issues, plant shutdowns became a regular occurrence. As a result, the PSCO began to question the economics of continued operation, and in 1989 indicated that the plant was under consideration for closure. Along with this, incidents such as the Chernobyl disaster in 1986 led to even further negative sentiments. Finally, in mid-1989, a control rod assembly was found to malfunction, and repairs were deemed too expensive, leading to the end of all operations. Defueling of the plant was completed in 1992, and the decommissioning process began immediately afterward. In February of 1995, the reactor core support floor was removed, marking the end of the nuclear generating station. However, plans to convert the station into a natural gas power plant were proposed, and construction on the first gas turbine was completed in May of 1996. This plant was a turning point in many ways, not just for Colorado, but for all of nuclear power throughout the entire world. Being the first and only nuclear power plant in Colorado, it helped usher in a new age of cleaner, greener sources of electricity for the state. Along with that, it brought with it a much greater understanding of nuclear power, allowing Colorado politicians to incorporate it into their agendas and helping residents understand the implications and effects such a plant could have. Colorado was able to gain extensive knowledge about the environmental impacts of a nuclear plant, from the impacts on nearby water and wildlife ecosystems to the impact on humans living near it. FSV also impacted the world of nuclear energy immensely. As mentioned before, this was an HTGR, or high temperature gas cooled reactor. Though not the first ever built, it was the first of this type of nuclear reactor to commercially provide power. This was a proof of concept reactor that did its job quite well. Though it experienced many issues, it showed the safety of these types of reactors, illustrating its capabilities to avoid a meltdown, even under the stress of many other issues. Today, many nuclear reactors are built using this archetype, based on lessons learned from the FSV power plant. Finally, one of the major reasons behind this reactor's turning point status is a result of how it was decommissioned. This plant was actually the first commercial-scale nuclear power plant to be decommissioned in the United States. The plant was shut down using many new, innovative, and safer techniques, including some, such as the method in which the graphite blocks were removed, that continue to be used today. Though the Fort St. Vrain nuclear generating station was not a completely successful power plant, it still served as a major turning point in Colorado's history, as well as the history of nuclear energy throughout the globe.